Hello everyone, this is Meenakshi Dilip Birari, working as a assistant professor in chemistry at Maratha Vidya Prasarak Samaj, Nasik. In previous lecture, we have studied Introduction to Surface Chemistry and some basic terms. Now, we are going to study Adsorption Isotherm. In today's lecture, we will study one of the type of adsorption isotherm, that is Freundlich Adsorption Isotherm. We know that adsorption is a surface phenomenon. The phenomenon of concentration or assimilation of a gas or liquid at the surface of a solid or liquid with which it is in close proximity or contact is called adsorption, or the phenomenon of accumulation or concentration of molecules on surface of a liquid or gas on solid surface is also called as adsorption. We know that in adsorption, molecules adhere to a surface of the material, whereas in absorption, molecules are drawn into the material. So, the accumulation or concentration of molecules on surface is known as adsorption. Already we have studied the difference between adsorption and absorption. The material providing the surface upon which adsorption occurs is known as adsorbent, and the substance adsorbed or attached is called adsorbate. So here the material providing the surface upon which adsorption occurs called as adsorbent, and the substance adsorbed or attached is called adsorbate. The substance having capacity or tendency to absorb another substance is called adsorption material or adsorbent material. For example, activated charcoal, rice husk, egg shell, etc. Adsorption is seen only in liquid and gases due to unbalanced force by attracting other substance with which they come in contact. The surface of any solid possesses active centers, cracks and peaks, and hence molecules that come in contact with it undergoes adsorption. So already we have also studied the mechanism of adsorption. The another term, that is desorption. It is the removal of adsorbed substance from the surface called as desorption. So it is reverse to the adsorption. These are examples of adsorption. Accumulation of dust on our skin when we travel in regions of heavy traffic. Adsorption of dyes like methylene blue by charcoal. Protection from poisonous gases. Solution of raw sugar becomes colorless when passed over bed of animal charcoal, and also air becomes dry in the presence of silica gel. Silica gel, it is a desiccant. It removes the moisture from the air. So these are few examples of adsorption. Now what is about adsorption isotherms? The process of adsorption is studied through graphs. It is known as adsorption isotherms. Graph between the amounts of adsorbate adsorbed on the surface of adsorbent and pressure at constant temperature. So the process of adsorption which is studied through the graphs, it is called as adsorption isotherm. It is the curve which is obtained by plotting the graph of amount of substance adsorbed per unit mass of adsorbent against equilibrium pressure or concentration at constant temperature. It is called as adsorption isotherms. The relation between amount of substance adsorbed by adsorbent and equilibrium pressure or concentration at constant temperature is called adsorption isotherm. In adsorption, adsorbate gets adsorbed on adsorbent. The direction of equilibrium would shift in that direction where the tension can be relieved. So there may be adsorption or desorption. Desorption, it is reverse to that of adsorption. In desorption, there is removal of adsorbate from surface of adsorbent. So it is reverse to that of adsorption. In adsorption, adsorbate gets adsorbed on the adsorbent. In excess of pressure to the equilibrium system, the equilibrium will shift in the direction where the number of molecules decreases. Number of molecules decreases in forward direction. Therefore, forward direction of equilibrium will be favored. So, in adsorption isotherm, we have to remember the process of adsorption in which adsorbate gets adsorbed on the adsorbent and the equilibrium will be shifted in the direction where the tension can be relieved, or also in excess of pressure to the equilibrium system, the equilibrium will shift in the direction where the number of molecules decreases. Limited numbers of vacancies on the surface of the adsorbent. After saturation pressure, adsorption does not occur anymore, and also at higher pressure a stage is reached when all the sites are occupied and further increase in pressure does not cause any difference in adsorption process. At higher pressure, adsorption is independent of pressure. So when we observe this type of the curve, here the limited numbers of vacancies on the surface of the adsorbent, and after saturation pressure, that is PS, adsorption does not occur anymore. At higher pressure, a stage is reached when all the sites are occupied and further increase in pressure does not cause any difference in adsorption process, so it is independent on pressure. So there are the different types of adsorption isotherm. These are Freundlich Adsorption Isotherms, Langmuir Adsorption Isotherm, and also bed theory or bed adsorption isotherm. We have to study all these types in detail. Today we are going to discuss first type, that is Freundlich Adsorption Isotherm. So let's see in detail about Freundlich Adsorption Isotherm. An empirical equation for the variation of the extent of adsorption with pressure at constant temperature over a limited range of pressure, which was put forward by Freundlich in 1907, is known as Freundlich Adsorption Isotherm. This isotherm is an empirical expression that accounts for surface heterogeneity, and it was put forward by Freundlich in 1907. Freundlich adsorption isotherm is based upon following assumptions. These are surface roughness, also related to adsorbate-adsorbate interactions, and inhomogeneity. So these are three important assumptions related to Freundlich adsorption isotherms. The relationship between x upon m and pressure of the gas at constant temperature is called adsorption isotherm and is given by the equation x upon m is equal to k into p raised to 1 upon n, where n is greater than 1. So Freundlich adsorption isotherm, it is an empirical equation for the variation of the extent of adsorption with pressure at constant temperature over a limited range of pressure. Mathematically, it is expressed as x upon m is equal to k into p raised to 1 upon m, where x is nothing but mass of gas adsorbed, m is equal to mass of adsorbent, x upon m, it is mass of gas adsorbed per unit mass of the adsorbent, p, it is the equilibrium pressure, k and n are constant, and this depends on nature of adsorbent, adsorbate and temperature. This n is greater than 1 because the amount of adsorbed gas increases less rapidly than the pressure. So in this equation, n is always greater than 1, therefore the amount of adsorbed gas increases less rapidly than the pressure. The Freundlich adsorption isotherm has no theoretical importance. It holds only up to medium pressure of gases. In case of adsorption of solute from a solution, the similar equation is applicable and it can be written as x upon m is equal to k into c raised to 1 upon m, where this c is nothing but equilibrium concentration of the adsorbed substance in the solution and m is the mass of the adsorbent, x upon m is mass of the solute adsorbed per unit mass of adsorbent, k it is the constant, n is also constant, empirical constant dependent on the nature of adsorbent and adsorbate and on the temperature. C, it is the equilibrium concentration. This equation 1, that is x upon m is equal to k into p raised to 1 upon m, may be tested graphically in the following way. The shape of the curve, when we observe, it is parabolic. If x upon m is plotted against pressure P, a smooth curve is obtained, which is shown in this figure. Here in the first part, the curve is linear because at very low pressure, x upon m is directly proportional to pressure. Then at intermediate, x upon m is proportional to p raised to 1 upon n, and at higher pressure, a limiting value of x upon m is reached, that is x upon m is equal to k. Thus, the curve has approximately parabolic shape. So, if the equation 1 may be tested graphically, the shape of the curve is parabolic. So, there are three parts. The first part of the curve is linear. Then, at the intermediate pressure, the x upon m is proportional to p raised to 1 upon n, and at higher pressure, a limiting value of x upon m is reached. The curve has approximately parabolic shape at constant temperature. So, at low pressure, adsorption increases rapidly. The amount of gas adsorbed per unit mass of adsorbent is directly proportional to pressure, that is x upon m is equal to k into p. Then at intermediate pressure, x upon m is proportional to p raised to 1 upon m, that means at intermediate pressure adsorption increases slowly, and at higher pressure adsorption remains constant, x upon m is equal to k. The amount of gas adsorbed per unit mass of adsorbent remains constant, so that the shape of the curve is approximately parabolic. Then by taking the logarithms of both sides for equation 1, we get log x upon m is equal to log of 1 upon n into log of p plus log of k. Plot the graph of log x upon m versus log of p. So this equation is in the form of y is equal to mx plus c, which is the equation of straight line. Therefore, if log x upon m values on y-axis are plotted against log p on x-axis, we get a straight line, which is obtained by using this equation y is equal to mx plus c. So the graph is straight line. Here the intercept of line on y-axis is the value of log k and the slope is equal to 1 upon n. The slope for this straight line is the value of 1 upon n and the intercept for this graph is equal to log k. It is observed that the Freundlich adsorption isotherms is applicable over a limited pressure or concentration range, and it is failed to apply at higher pressures or at the higher concentrations. So from these graphs we can consider the limitations of Freundlich adsorption isotherms. One is it is applicable to moderate range of pressures or concentration, and it fails at higher pressure or concentrations. So what are the limitations of Freundlich adsorption isotherms? Freundlich equation is purely empirical and has no theoretical basis. The equation is valid only up to a certain pressure and invalid at higher pressure. The constants k and n vary with temperature. The Freundlich adsorption isotherms fails at higher concentration of the adsorbate. So these are the few limitations related to Freundlich adsorption isotherm. In today's lecture, we have studied adsorption isotherm and one of the type of adsorption isotherm, that is Freundlich adsorption isotherm. In next lecture, we will study Langmuir adsorption isotherm, the another type of adsorption isotherm. Thank you.